All right. So, hello and welcome to this uh, new lecture in the series of lectures on your elective course. Now, see, in this series of lecture, maybe I will try to cover this thing within one lecture, but if it's getting too long, then I may have to break it into two components. Okay. Uh, this is going to be a very interesting thing. Okay. Let me explain why. So, because we have already studied regarding ICC profiles and how to standardize or how to printers or how to calibrate, characterize your equipment, that is your camera, monitor, your printer, all these things we have already seen, right? Now, in this lecture, what we are going to do is we are going to implement that practically. We are going to create ICC profiles, version 2 ICC profiles for our devices, specifically for our scanner, sorry, for my mobile phone and for my printer. So, this at the time of recording, I will be developing two profiles. One will be for my smartphone, and the other will be for my home printer. It's basically a inkjet printer, which normal desktop inkjet printer that we have. So for these two devices, we will be developing ICC profiles for. I have also shown you how to develop the custom profile for your displays, right? For your Windows display, how you have I will not say it is that you have calibrated your device or like that, but it is through the method of adjustment that is available in the color management option on any Windows PC for that matter. Okay, so how do we achieve this? How do we you know create version 2 ICC profiles? With the help of this tool, that is Argyll CMS, Argyll Color Management System. It's a very useful and a very powerful color engine that has been developed by Mr. Graham Gill. It's, I think, it is perhaps one of the most important tools for us, because at the moment we don't have any proprietary uh, color management system at our disposal, or any profiler at our disposal. Neither do we have any equipment in the sense that for color measurement we have printers and all these things. Not, we're not talking about, when I say equipment in this term, a device in this context of color management, always consider that to be your a spectrophotometer. Okay, so we don't have a spectrophotometer right at our disposal now. Then what to do? So I came across, and I uh, kind of stumbled upon this Argyll CMS a few years back, and since then I have used it for various purposes, for the development of your color profiles, version 2 compliant ICC color profiles, and it is giving quite good results, considering the fact that I am not using any spectrophotometer for measurement purposes. I am using just my smartphone camera for measuring the colors, and even then the quality of profile, I would say, is quite nice. I will also, there will be, in the last segment we will do something which is known as the round trip test. Round trip test means that how it's a methodology. There are various methodologies of testing, but round trip is one of the most popular and widely used method to calculate quantitative quality of your uh, created ICC profile. What we do is, basically, we take an image, we convert it into the from the device space to device independent space using the A to B LUTs in the ICC profile created, and then we convert it again back from the independent space to some other device, to the device space, using the B2A table that is present in the same profile. And the difference, color difference between this before conversion and after conversion, that we compute, and that this is how we get the metric, or this is how we get the quantitative method to test the quality of our ICC profiles. Okay, So this is something which is called a round trip test. For that also we have one technique. We have some tool for testing that. We can do it manually also. I have done it manually also, and through some software also. I will show you how to do it both manually and through this thing. So I have used a lot of Python code for at least the computational part, for quality assessment part of the profile that was created, and rest of the things using the color science module that is developed by Thomas Mansankel and his team, uh, that I have used for creating some basic code. It's a very powerful and very useful module. So because that is not really related to our area of our domain, that is why I'm not going to show you all that. But this is just for information. Some more advanced learners amongst yourselves can go ahead and take a look. It is color with a U, color dash science module for Python. So let me just go ahead and search it, if it is if I can show you that module as well. Yeah, so I think if you just Google it, so this is the PyPy page of Python, how to install it, and this is your the home page for the project. Okay, and this is your documentation page. So what I normally do is I just go to the documentation page and read the documentation for the part that I am looking after, or that I am searching, and you can just search the docs, and you can get all sorts of information from this page. Okay, so I'm not going into details of this particular component. So so coming back to our topic at hand, that is how to use Argyll color management system to create version 2 compliant ICC profiles. It's a very powerful tool. It's a color engine, color management system, all combined together. So, just what you need to do is, first of all, do one thing, that I'll tell you how to install the Argyll CMS in any computer or in any Windows PC. So, because I think we're all using Windows PC only, I will not. I personally don't know anything about how to install this on Mac or anything, but I don't know how to work on Mac because I have never worked on a Mac. So I have always worked on a Windows PC, so my entire discussion will be based on in the PC platform only. Okay, so documentation is there for how to install it in Mac and all these things. If someone is using it, then you can see all that. Okay, now next what I want to show you is that what to do, basically how to kind of install this Argyll CMS in your PC. First, you need to go to any browser and just go to this portal, that is Argyll CMS. Argyll has got double L's, argylcms.com together, right? So once you go, this page, this home page opens up, and all sorts of information is provided in this home page, right? So what are the important things over here? So initial, this current version is being stated, and its release date is stated. Some you know one prayer for contribution is also there. Now so these are all the people who have contributed in some way or the other. Now one important thing that I wanted to mention here is that, see, for quite some time now, I was trying to create ICC profiles for our devices, that is for the monitor, your scanner, your desktop printers and all these things I was trying to create. Now because we don't have a 4-color offset, so we can't create a ICC profile for such CMYK or commercial printing devices. But if we do have something of the similar sort at our disposal, of course that is also possible to create a ICC profile version 2 compliant for that device using the CMS. Now there are various color management systems and profilers which are proprietary, right? So naturally I'm not going to name any of those. There are a variety of such profilers available today in the market, and in the graphic arts industry, printing industry, we normally use many such proprietary software. They are very easy to use. That is the one very I would say very nice thing about the proprietary system, that they are very user friendly, right? But then again, they are very costly, and most importantly, they come in the form of modules. That is, you need to buy the modules that is for monitor profiling. If you want to buy the monitor profiling package, you get only that. If you want that to be extended to all your devices, that is printing devices and all other devices, then you need to buy some other additional modules and all these things. So ultimately it is, you have to pay for those things, and they are premium products and premium services that are currently offered, and quite rightly so, because these products, there are big organizations, big companies who are creating all these products, and naturally they are creating wonderful products, very useful tools, powerful tools nonetheless. So naturally it comes at a price, and it's quite justified. But what I personally am an advocate of is the open source, free and open source software movement. I am personally very much benefited, and I really like this concept of free and open source. So mm, there is this saying in the open source community, that is, what does this free mean in free and open source? This is not a lecture on free and open source software, but before I begin, I cannot I cannot stress enough how much useful this Argyll CMS is for us. Because we, first of all, we at this present moment, we don't have a profiler, we don't have a spectrophotometer. In spite of that, this tool is helping us create as, and that is nothing sort of a wonderful thing for us. Okay. So yes, I was talking about this free. uh, Free in free and open source is often associated with, free is not like free food or free sweets. Just for example, free is more associated with free speech, right? So this is what free in free and open source means, right? So this is such a operating, I mean, this is such a uh, system, which is, I will show you the, I will show you the um, that statement, where I think I had that statement somewhere over there, but I will get to it later on if I don't find it over here. So what is that what does that mean, free and open source, for this particular system? See, this is an open source platform. That means the source code of this, how this program was created, that is freely available on GitHub, okay, or SourceForge maybe. So as soon as you click on this option, click on this link, then you can download the source code for this file, and if the more sophisticated users can definitely tweak and modify such source code to their own benefit, to suit their own purpose. But we don't need to do that. We are just using it for creating the profiles for us, right? So that is why this is a open source platform, that is, the source code is actually given. Now here, as is, I just like to open this commercial use tab, where the statement about the use is provided, right? So most of the source code and provided executable files are copyrighted works licensed under the GNU license. And while this license permits them to be freely used, they or works derived from them can't be copied or sold without providing the source code. For all the gory details, the license is provided. Code that is copyrighted by me, that is Graham Gill, which composes the vast majority of the Argyll CMS, may be available for licensing on terms other than the GPL, so that it may be incorporated in closed source products. For more details, they have to contact the people. Now, uh, so see, it is also very much important here, the last line, that note that at that current time, only a limited portion of the code is available for licensing in this way, self-contained libraries, etc. Simply because I am not in the position to provide level of support that all the current code base would demand, were it licensed in that way. Licensing that way means this non-GPL based, non-GNU based license, that is. So let me explain what this is all about. See, everything, this is a product, that the Argyll CMS is a product which can be used freely, right? And the source code is also there. But the main philosophy of the GNU license is FOSS software is that whenever you are creating some work out of it, right? So maybe you have downloaded the source code and you have made some modifications, and again you are sending it to someone for wide use, right? You are uploading it to some server for wide use. Then you cannot simply submit, or you cannot simply upload the executables. You definitely have to provide the source code, preferably the original source code as well as the modified source code which is behind this new which has been modified from the original to create the new executable. So that is the meaning of this. But again, another thing that has been written over there, that some portion of this Argyll CMS, the vast majority, they can be incorporated within a closed source product. So for example, company XYZ is making a color engine or a color profiler. They have selected Argyll CMS. In this context, let me also say that there is another very popular CMS which is known as the Little CMS, uh, that is also widely used in various closed source products by different companies to create color engines or incorporate these color conversion systems or color management systems into their own products. So that is also possible with this. Okay, so that is a non GPL licensing, that is different from this open source thing, right? So this is very important. This is the core philosophy of the open source movement, that is whenever you are changing something, whenever you are modifying something and sending it for wide publication, then you should definitely upload the source code along with this, so that people may view the source code, and such that the concept of this free and open source is available to you. So now you understand what the word free means in free and open source, right? It is free to be used, but whenever you are deriving some work, whenever you're modifying something to create something out of it, of course you need to upload the source code or provide the source code along with it. So that creates that sense of this free and open source software. So I cannot thank the people associated with this project who have created this beautiful thing that is Argyll CMS. Okay, especially for people like us who uh, have a lot of difficulties in and deficiencies. So at least I can show to you, my students, how to create a ICC profile and what it all means. So till now, all the lectures you have seen that I am giving you a very theoretical approach and theoretical what is there in the profile, how to create this and that, the mathematical interpret, all these things I have already told. But now comes, especially for a technical institute like us, it's very important to get a hands-on experience. So that has only been possible because Argyll CMS is open source and free and open source in nature. Okay, so that is why I am so much repeating myself, although you might say that what is the big deal here, but hope one day you will understand what is the big deal here and the meaning of, or the significance of what I'm trying to convey uh, through this. And that is why I am so much thankful to the free and open source software movement as such. Okay, so now a lot of things have been I have said at the beginning only, but now let us consider that how to use it and how to install this product in your PCs. See, uh, the Argyll CMS, native Argyll CMS system, that works on the command prompt mode. That is, it's command driven, right? There is no graphic user interface, right? That you may find in some of the more uh, mm, premium products that are offered by different companies who are offering this profilers as their product. So there is that's why I told it's very easy to use. Those profilers very easy to use because everything is in the graphical window mode. Because see, we are not from the computing background. We know very basically very little bit about computing. We have very little computing knowledge. Okay, I mean coding knowledge and all this. We get very, I personally get very much anxious when I see the command prompt without any GUI. I have to type in all this, so this becomes very difficult for me. So that is natively not available to the Argyll CMS platform, but some people have created this. See, this person has created this more accessible display cal, which is a display calibration tool based on the Argyll CMS, that is a GUI. Okay, that is GUI driven, not command driven. But the code source code that has been used in creating that system is Argyll CMS. Okay, but we will not use any of that, because one thing is that we are not using any device meaning we are not using any spectrophotometer for doing our measurements. We will do what we call what the author of this Argyll CMS has called as the poor man's colorimeter. So we will use something which is known as the poor man's colorimeter. So why? Because we are not using a colorimeter, we are using some version, some made up version of the colorimeter, because I'll be using my phone, so that my phone becomes a poor man's colorimeter. Okay. So but in this GUIs, what I have seen, I have tried out this GUIs also, this display cal, and I think another is there, Coco is there. Yeah, this sorry, Coca is there. This person has developed this Coca, and this little G. I have tried out all these things actually. Display cal, little G, Argyll, and Coca. All these GUI based Argyll's system I have tried, but in all these things you need a in order to make the measurements uh, you need to attach or install a device with your computer, so that that can measure the color patches of the test targets. But since we don't have that, we'll go simply for the command prompt driven. So initially it may seem a little bit challenging for us to understand, it was for me at least, but it's not that difficult, because everything, the documentation in this system is extremely nice, it's extremely detailed. So we hopefully we won't face any problems while creating our profiles. Okay, so now what I wanted to show is, yes, now how to download the executables, and we don't need to download the source code, because we, first of all, I want to understand what the source code is all about, because I have absolutely almost near to zero knowledge in coding, and so something in which I don't have knowledge, I cannot also modify. So no meaning in downloading the source code. If someone of you are more interested, you can just simply click on this. I think this is hosted in SourceForge, or I think GitHub now. So you need to view it. What we are interested in is this one, right? This Windows executable. There are other executable for Linux and OS X also, but we are more interested about the Windows executable, right? So we will open the Windows executable. As soon as we open this Windows executable, we'll also click on this online documentation, right? Because that will be helpful for us. So you see, this is the Windows executable that is your that has been your you can download the Windows executable file, exe files, for Argyll CMS installation purposes. Depending on what processor you have, if you have a 32-bit or if you have a 64-bit, both the things are given over here. So no issues regarding that. Okay, so you just simply click, and one, I think, zip file, something like let me just go ahead and show you, something like, yeah, so this one, this one actually, something like this particular folder will open, I mean will be downloaded. This is around 32.5 or 33 MBs size, so this will open up. Okay, now what you need to do is, once that is downloaded, you need to unzip it. Okay, so let me just go to the installing page. This will provide you the guide on how to unzip and install it. Okay, so what you need to do is, you need to unzip it. Okay, you need to unzip it in a particular folder, maybe in your C drive. Okay, but here they have said that not to do it in program, under program files, but accidentally I installed it in my program files only. So let me just go ahead and show you where I installed it. So what you need to do, I'll just explain that process really quick. See, suppose this is the zip folder that has been downloaded, right? So what you need to do is, you simply need to unzip it. You simply need to unzip it, extract. If you click on extract here or extract to, if you click on extract here, it will be extracted in this folder, but you should always select this extract to create a folder, right? Or you can select extract files if you want this to be extracted in a particular folder in your computer. So what I have done is, I have downloaded it, I mean I have extracted it in my, I think, program 86 folder, this folder. There you can see I have got this folder downloaded, right? So this is the unzipped folder with all the components. These are the components within, right? We don't need to go into the details just yet, but this is the first step of, so there is no like there is no window that will come and say yes, 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 and go to the next page, yes, you agree, all these things. This will not come. Simply you need to extract it and store it somewhere, extract the files and store it somewhere in your computer in a single folder, right? Then what you have to do is, then another very important thing, I think, what you have to do is you have to change the path variable. But let me show you that. Give me a second, I'll show you that. So next step, what you need to do is, it is also written in your documentation, I think, that you need to go to the this panel. Basically, if you're using Windows 8.8 and above, then you need to go to desktop settings, control panel, system and security, system advanced settings, and environment variables. Okay, so or you can do, just go to click on the start button in your keyboard, or sorry, not the start button, Windows button on your keyboard, and just search environment variables. There you will see the one option, edit environment variables, and this type of a page will actually, or this type of a window will actually open up. This white window that you are able to see, this will actually open up. Okay, so what you need to do is, you simply need to click on this environment variables, right? And there you need to search for this path variable, this variable named path. Okay, so what this variable is, just double click it, and there you will get the option to add a new path. So what you need to do is, you need to click on new, and one like this type of a thing will open up. This, there you have to, you need to again go to that path where you had installed your, or you had copied or extracted your Argyll folder. So like this, so the path is this one, right? So this is the path, right? You simply copy this and then you paste it. You click on new and you paste it and you click on OK. So this type, so naturally this type of a folder will be appearing here, right? And you need to, I think, no, this one you don't need to do. You only need to do this user variable for your specific user. So this is my user. So for this I have edited the path, right? And then you click on OK once again, right? Because mine is already added, I will click on cancel, and once this goes away, and then again click on OK, right? So this is how you edit the environment variable. So I think environment variable, when you add that path to the environment variable, it makes those commands available to your system, to that particular user. Okay, why it is important, I will show. So till now what you have done is, you have successfully installed and ensured that your all the variables and all the all the commands and everything is available to the user on which you are currently using, right? Now next part, we will start to take a look at the uh, so next part, we will start to take a look at the documentation part that I had already opened up. So this thing you have already done correctly. We don't have any instruments, or we don't have any devices, so we don't need to get into this component actually. So this component of this part is how to install your devices into the, and ensure that it is connected with the Argyll driver. So this part we will not get into because we don't have any. Now this is what the documentation page looks like. Okay, there are a lot of uh, useful information available in the documentation page. A brief introduction to what color management is, and some great articles are also there, right? And again, the source code is again hyperlinked over here. You can view it. These are some of the equipments that, or these are some of the instruments that is compatible with the Argyll system. So I think devices from all the companies, I think most, not all the companies, maybe most of the renowned companies are being accepted or are being allowed to be used with this particular driver, Argyll driver. Okay, so what we need to do is, we simply need to say, again, the copywriting and license is provided. This is based on, so just go ahead and search this, what the meaning of FLOG union licenses. But the overall overarching message is that it cannot be copied, sold, or made available to users interacting with them remotely through a computer network, without providing the source code. So this is the main thing. You cannot provide the executables, just the executable standalone, without providing the source code. For the source code, you can simply click on this link and you can view the source code, and you can link this source code to anyone whom you are sending the executables to. Okay, now what we need to do is we need to get into some of the examples. But before we get into the examples, let us first try to understand how the entire system works. We will be using only a very small section of the entire system. We'll not be using the the entire Argyll system, all the features and all the commands will not be using. We'll only be using a very small portion of the entire Argyll system. So a wonderful flow chart has also been created by the author. Let us click on this flow chart and let us take a look. Okay, let me just yeah. So this is the Argyll system. So don't get afraid and don't get frightened by all these commands, because initially I also did not understand what all this meant. But because the documentation part is so nicely done by the author, you simply read it, and you only thing you have to do it is you have to execute it. You have to implement that for your system. Of course, there are certain things that you need to modify, and certain, I mean, the execution part, not the source code. The execution part a little bit here and there you need to modify, but that is also very easy to do. I'll show you step by step everything. So main thing that you need to do is you need to first see, this is what we are doing really. We are going for characterization or profiling of our camera and our instrument, meaning that this your not the instrument, I mean it's for the printer actually. So this is the thing that we are doing. Okay, the display calibration we will not be able to do without the help of the instrument. We will definitely need an instrument for that. So this display calibration part, this we are not doing. We are only doing the printer calibration and the camera calibration. Okay, so what we need to do is, first, this is a common flow chart actually. So what we need to do is, first there is this target meaning target generation. We need to develop a target. First we need to generate some targets. Target is the color patches. That is, you need to first generate it. Then if you're if you're profiling your camera, you need to click a picture of that target. If if you are profiling your printer, you need to click a picture, you need to print that target. So what target is to be generated? What will be the format of the target? What will be the page size? What will be the formatting? What will be the number of such targets? That is determined using the target, your command basically. So target is your command. Next, what we have got is the print targ. See, print targ. Print targ means we are going to prepare a PS, EPS or a TIFF file for that target. So target generation is only generating that target. It's not giving you the output in a printable or viewable file. For that you need to generate the print target. Okay. So what this, another thing is very interesting here. Every command is generating one file. I will explain what this file is as we go along, but I will give you a very brief overview. See, as soon as you are creating this target, a file, whatever the name of the target you will be preparing, that name you have to basically give. So what you need to do is you need to simply write down this command target with all the variables, and the resultant of that execution will be one file with .ti1, that is target information, chart target information file one type, first type, that is ti1 type. So what is this ti1 file that will be created? Ti1 file will be creating the expected values of those color patches. What does this mean? So let us say we are printing or we are creating a file with 400 targets. So what is the expected XYZ value, price stimulus value of those patches? That information is given. Then after printing, we have to measure it with an instrument, and then we have to find out what is the actual price stimulus value after printing, so that we can use both the data to create the profile. Okay, so that will come to later on. Next, after the TI1 file is created, we'll use this print target. That means we'll use this T1 file, TI1 file to create a TIFF file. TIFF file means viewable file, or a PS file. That is also, that is, PS is not viewable, but we can create a PDF out of it, we can print it, right? So print target is going to create a viewable or printable file of the targets that was generated, right? Now once we have got this TIFF file, this TI2 file is being created. Okay, TI2 file is being created. TI2 file will contain all the this information that is necessary for uh, uh, profile preparation. Okay, another file is also created, that is the CHT file. You see, CHT file is also created, this one from the printer. What is the purpose of the CHT file? CHT file. So let us assume that we are using an automated device like I don't want to take names of device of any particular brand, that is why I'm refraining from using any. So there are various I mean automatic tables, scanning tables, and there is a table on which you place the test chart after printing, and there is the device, the spectrophotometer. Automatically spectrophotometer will move itself, and it will measure all the patches if you give the command. So this type of, so how will the spectrophotometer know which, where to start from? Because the order is to be maintained, how the patches are there. Similarly, you have to maintain that particular order. How will the spectrophotometer know? So for that order, or what is the what is the arrangement of the patches, where particular patches are, that arrangement file is the CHT file, chart information file. Okay, so that is one done. After this print arc, then we have got this uh, chart read. Chart read is then we will take the printout of that, this thing of the chart. But for the chart read option, what we are going to do, we will not use this chart read. Chart read means we have an instrument connected to our computer or the Argyll driver, and then we have taken the printout of the test chart, and then we were going to measure it with the help of the instrument. Because we don't have instrument, we will not use chart read. But that is the beauty of the Argyll CMS. The authors have created this scanning option also. Okay, the scanning option also. What is the purpose of the scanning option? Let us say you don't have any sorry, you don't have any measurement device. Then what to do? You are using your scanner or a camera, phone camera, to prepare this thing, to create the profile or to measure the patches. That option is all, which the author has rightly called the poor man's colorimeter. So your camera or your scanner will behave like a colorimeter and will measure all the patches basically. Okay. So once the scanning option is provided, basically once the scanning option is used, this means we will basically take a photo, and then we will use the scanning option along with that photo and other details to create this TI3 file. This TI3 file will contain, that is again chart target information 3 file, TI3 file. TI3 file, what will what will it create? This TI3 file is going to create your data or a chart which will contain, or a file basically, which will contain the XYZ or tristimulus value of the patches that was measured, that was obtained. Okay, what the printer actually printed. So TI2 files is what is expected tristimulus value, and TI3 file is what was actually generated, okay, by the printer. So once this file is ready, this file will be used alongside this call prof, that is color profile. This is actually the command which we will use to create the ICC profile. Okay, so this call prof we will be using to create the color profile. Once the profile has been created, we can calibrate it, but we will not calibrate our profile. We'll see it. We can use this color profile to the generated color profile alongside this CCTIF command to convert any image using that profile. The same thing that we do in Photoshop, that can be done through this system also. We'll use a particular generated profile alongside the CCTIF command to convert any image to your that particular profile. Another thing, the generated, what will be the nature of the gamut that is generated by the profile, that we will be seeing using the gamut vision tool. that I have already shown you, but there is also that system here. What you need to do is you need to create a ICC gamut file, right? Using this, you need to create a gam file, .gam file using this ICC gamut command, and then you need to use that gam generated gam file alongside this view gam command to visualize that gamut. To visualize this gamut, I think I have one, the one that I had already created, that I have, I think, somewhere over here. Let me just go ahead and uh, open that. Let me check whether it will open here or not. I hope it should open. Yeah, so this is the gamut that was of my ICC profile that was created for my printer. So this is my printer gamut, really, printer ICC profile gamut. So this visualization tool is also there. Okay, so this is the overview of the entire workflow. Hopefully it is understood. Now, as soon as we go ahead and understand individual commands and how they work, I'll show you the working demonstration. Then I think it will be much more easier for you to understand. All right. So from here, let us go back to the actual process through which we can do. We can just close the uh, major tools along with the flow diagram, and now let us take a look at some of the important commands that we will be using. Okay, so for calibrating devices, we have got two commands, that is dispcal and printcal. We will not be using either of those because we will not be calibrating display through this method, or we will not be we will be using this printcal method for our printers. For generation of the targets, there are two commands that I've already shown you. One is the target, another is the print target. That is, target is generating the target TI1 file, and print target is generating the TI2 file. Ultimately, when you have scanned it and when you measured the file generated, I mean the print generated from the print target command, then the using your scanning option, there will be we'll be using the scanning option to basically create the TI3 data. So the normally, if you had an instrument with you, then we would have used this chart read option to create the TI3 file. But since we don't have, we will use a TIFF file to and the using the scanning option to create the device TI3 files. Okay, so this is more or less the all the types of, and of course ultimately we'll be using the colprof, that is the color profile creator command for creating the RGB, I mean the ICC color profile, version 2 compliant ICC color profile. Okay, and so without now further ado, now let us take a look at how to actually process, go for the actual process of this entire thing, right? So now let me first take you to the folder where I have stored actually different things. Okay, so this is my working folder, right? Working folder is basically your the folder where you are creating the profile and where we have all the data stored, right? Now in our case, what we are going to do, this is my working folder and this is my pathway, right? Remembering this pathway is quite essential. Why it is important, I will tell you later on. Now you can see a lot of things have already been created. I'll just give you one kind of a idea about by creating a new folder. So let me go into inside of the new folder. I'll just store some important things, right? What are the important things that I need to be assured that these files are already present in the working folder before I start creating the profile? First of all, if you are creating a scanner profile, you need a TIFF image of the uh, target that you are going to profile your scanner or your camera with. So that is my color checker photo. This I will copy and I will paste in this folder, right? Also your standard RGB profile with which you are working. So I am working in a sRGB environment, so I will store this as well in this working folder. Along with this, I also need something which is known as the CIE file. Now let me get into this component, what it all means, CIE file and all these things. Let me get into this. Okay, so if you open the CIE file, this file is basically can be CIE or txt, that is the text file, but you can open all these files using your notepad. So what you can see in front, so let me just add this value. Okay, you are not able to see, let me just add this thing. Yeah, so as you can see, this is basically your CIE file. So what does it contain? One thing you should be very much aware about is your what is the method through which you are going to profile your imaging device. That means your scanner or your camera, which you will use as a poor man's colorimeter for measuring the test patches from your printer, generated by your printer. Okay, so what is the first step? In the first step, we need to select any standard test patch. So what type of test patch we have? We are using this Macbeth color checker 24 patch test chart. So this is our test target. Okay, so what is the first thing that we need to do? We need to generate or click a picture of this of this test chart and use it for creating the camera profile. Okay, camera ICC profile. For this basic thing, what information you need? You need you need this CIE file. What does the CIE file contain? The CIE file contains what is the tristimulus value or what is the LAB value of all the patches. You see, it is written here A01, A02 up to A06, then again B. So what does it mean? It means that this is A, this row is A, this row is B, this row is your C, this row is your D, and this is the first patch, second patch, third, fourth, fifth, and sixth patch. So this patch becomes, this is known as dark skin patch actually. This is light skin patch, this is light blue patch, and this is like that. All these names are given for the patches, but that doesn't matter. So what we have is, first we will be considering the LAB value, that is the device independent value for all these patches. Now whenever we are getting these patches, all these patches basically come. So this is the so let me just try to okay, because of the background I'm not able to show you. So this basically comes with a standard, all the test chart basically they come along with this chart. Okay, so this chart, if you can see this chart, this is the chart. This chart contains all the information about this test target. What information? That is, what is the tristimulus value or the chromaticity coordinate, or what is the LAB value. All these things are given by the manufacturer itself. So this information, this chart information is basically given in this CIE file or the text file. So what will be the tristimulus value? What is the tristimulus value, or what is the LAB value? In this case LAB, what is the LAB value of the first patch, second patch, third patch, and why is it needed? What is a profile? Basically, profile is some form of transformation file which contains A to B and B to A LUTs. So that means what? It is transforming from one color space to the other. So what will it do? It will take for building that profile, what basic information we need? We need what is the actual LAB value of the patch, and what my camera is seeing, what is the LAB value of the patch. So that is why we need minimum of two things, right? This CI, or this is sometimes called the reference target. Okay, this is the reference file actually. This reference file is normally provided by the manufacturer of the test chart. All these test charts are basically available to be purchased. Okay, so this is the as you can see that this is basically your test target, right? So I'll just show you. This is the test target and the corresponding LAB value of all these patches, A1, A2, A3, B1, B2, B3. All these patches are given in that reference file, which is sometimes, in this case, as you can see, that this is given as extension is basically CIE.CIE. This color checker mod, this is basically your CIE file, or the sometimes in text file also it can come. So this is one of the basic necessities. Okay, another necessity is that this will be provided to you by the manufacturer, this reference file. Okay, another necessity for you is to get the I think the CHT file. Now the question is, what is the CHT file? This also you need to copy to your working folder. Now question is, where will you get this CHT file? CHT file is given because you see the Argyll system. I'll show you something. uh, I'll show you something. Wait, this Argyll system has got uh, or supports various test targets. Okay, so this is IT 8.7 stroke 2. This is the 24 patch color checker, Macbeth color checker. This is your color checker DC. This is your X-Rights color checker passport. This is Detect Macbeth I1 Pro scan target. So all these charts are basically supported by your uh, Argyll. Now the question is, how will the Argyll know what is the how the patches are arranged? That means where exactly is the this particular, since we are using this, where particular is the this dark skin patch, where is the light skin patch, what is the white patch, what is the black patch, how will it recognize? So that recognition, patch recognition file is basically your CHT file. Okay, so where can you get this patch recognition file? Simply go to your original folder where you had extracted your Argyll, right? So there you will get this bin folder. In that bin folder you will have, I'm sorry, not the bin folder, I'm sorry, the the ref folder. In the ref folder all this information is already given. The reference file, standard reference file for all the standard charts are given. Now from here you have to find out where your color checkers CHT file is given. So see, these are the three color checker files. What information is given? This is the CHT file. This is the CIE file, because I am using a different color checker. My a different color checker I am using. So that CIE file, the standard CIE file I am not using. Okay. So first of all, you need to copy this CHT file from this ref folder to your working folder of your Argyll. So this you have, so I think, yeah, I had copied. So this is your CHT file, right? So this becomes your CHT file. Now the question is, suppose you are using a color checker, okay, but the values that you are seeing in the LAB values that you are seeing in for the particular, let me just go ahead and okay, let us assume that you are using this color checker file only, but color checker test target only, but the reference file that is given with you by the manufacturer, that does not contain these values. Okay, so what you need to do, you can simply change the values, or you can use that file which was provided, or the CHT file, CIE file, or the text file that was provided by your manufacturer, or you can simply change this value and save it also in your working folder. Since I am, my values, the chart that I am using has different values from what is actually provided by the Argyll system. That is why I am using this. I have changed those values, and that is why I have created this color checker mod file. Okay, so these are the three basic things. That is the TIFF photo of the color checker, your CIE or the text file, reference file, and your chart recognition file. So let me open the chart recognition file and tell you how it is appearing to be like. Let me just open this. Yeah, so this is the chart recognition file. So here you see, this is basically containing the information about which position, which particular your chart or the target is appearing to be. Okay, so if you simply go down, see all the positions are given over here. All the 20 patches, position for 24 patches is given over here. So this is the chart recognition tool basically. Okay, or chart recognition file basically. Okay, now you see what is there. Another thing is there. Let me just close this one. Okay, so yeah, so yes, so this is the that CIE file. So let it be here itself. Now these are the basic things that you would need to create the profile for your camera, right? Now how to generate this TIFF photo? See, this is the TIFF file. Normally if you are using your smartphone camera, it will be generating a JPEG. Also there is a very important thing that I want to mention over here. Whenever you are taking a photo of the chart of this test target with your scanner or a camera, scanner is a closed environment, There you don't have to, care about the exposure and all that. But whenever you are taking the photo with your camera, I mean your camera or your smartphone camera, whatever it is, you need to ensure that the situation of the scene in which you are taking the photo, the exposure, the light, type of light, all these things, they are exactly same throughout for all the later on photos only also. So for example, here you need to take a photo of the of your the test target, right? Then when we will be using our camera for taking the photo in later on for the test targets that will be printed with our printer for printer profiling, all these photos when you take, you need to ensure that the scene and the exposure levels and all this uh, um, situation, that is the ambient situation during taking the photo, is exactly the same. If it is not, there will be some deviation and there will be higher color difference actually. All right. So now what I want to do is, I want to go ahead and create my color profile for my uh, this particular phone. Okay. Now what, for this, what I need to do? For this I need to go to command prompt. So what is command prompt? Just go to Windows and R, press Windows R in your Windows PC and type in CMD command, CMD short form for command, and press enter, and this type of a command prompt window will open up. See, you have to ensure that whatever is your working folder, that is in the command prompt present over here. So what is my working folder? What is my working folder? My working folder, in order to change the working folder, what you need to do, you need to type cd and you need to type in the address of your working folder. So my working folder is located in this directory. So let me just this is a long directory actually. New folder. Okay, so with this command, that is cd and the entire directory, I have pressed click I mean written it down and pressed enter, and see now my present location is within the new folder. So my present location is in which folder? My present location is in, so wait, yeah, my present location is in this particular folder. I am now working in this particular folder. Okay, so now let us go back, and first thing that I want to do is, now I want to create a scanner profile. So what you need to do is, you need to use the scanning option or the scanning command, right? And you need to write dash v. What is this v? V stands for verbose. Verbose means, you will see, whenever whatever computation is going on in the background, that will be coming in front of you in this command prompt. So you need to ensure that this verbose mode is on, so that you can see the progress. Basically, it is what progress your command is actually making. Right now, scanning is the option which will create the ti3 file. What is the ti3 file? Ti3 file, oh, before that I forgot to tell you actually. So what is, how to save the image that you clicked with using your phone in TIFF format. Okay, best one way of doing it is, suppose you, this is the JPEG file, you roughly crop it. Do not edit it in any way, please do not edit it in any way. Use the raw file which was clicked by your camera, and simply open it in any window and crop it using any application and crop it. Please ensure that there is no color change occurring or no color conversion is occurring during this process. So we crop it, and then this is in JPEG mode. What you need to do is, you need to convert it in, this already is in TIFF mode, but I will show you how to convert it in TIFF mode very easily. So this is Microsoft photo viewer basically. So go to file and click on this export button, and there you will see export with file format. Here you choose, it will be normally JPEG, here you choose TIFF, right, tagged image file format, and click on OK with the appropriate file name, and do not change this size, keep it in original size please. Okay, once this is done, then you have completely created the TIFF file. Push the TIFF file or paste the TIFF file in your working folder. This is the working folder where I have saved my file. So if you just hover, I will hover my mouse, see it is a TIFF file, right? So the name of my TIFF file is color checker photo. Okay, right. So now what you need to do is, you need to simply go to the command prompt and you need to use the option that is or the command, that is scan in space dash v space, what is the name of your photo, color checker photo dot tif. This is the file name of your this thing of your photo of the color target on the test target, right? Space, again space. Now you have to name the CHT file so that it can correlate the TIFF and the CHT file, so that it can find the location of the individual patches. Okay, what was the name of my this thing patch, I mean the CHT file? Let me just go ahead and check. The name of the CHT file was, I think, color checker. Yes, this was color checker, right? So I will write simply color checker there. So that is color, yeah, so color checker.cht, that file, space, again you have to write the name of the reference file or the CIE or the text file that contains the actual LEB values of the patches, right? So what was the name, if I remember correctly? That was color checker mod dot CIE. That was the name of the file. Okay, so and when this is done, simply press enter. Yeah, so now your TI3 file has been created. See, color checker photo TI3 file has been created. So what does this TI3 file? Let me go to the working folder and check what this TI3 file basically contains. See, I think this one is the, yes. So this one is the TI3 file. So this TI3 file contains what was actually obtained, what was the XYZ value. This is the first three bytes. So this is basically the format of any the CGATS file format, basically this is known as. So this will contain information about some test chart. Okay, so what does it contain? This is the descriptor, name of the file. This is the descriptor, what it contains. Target chart information 3, originator is Argyll chart, created on device class input, because we are preparing a profile for your camera as an input device. So this color space, what are color spaces given, XYZ and RGB values are given. This is the sample ID. This is the header basically of the file. So the first header, this column header name is sample ID. So this is identifier basically which patch we are talking about. Then we have got the tri-stimulus value, X, Y and Z value. This is X value, Y value, Z value. Then this is the RGB value, RGB value. This is the standard deviation of the RGB values. We don't need to bother about this. But these values, that is the XYZ values, are all written such that they are all normalized to ensure that Y has a value of 100. So based on that, these XYZ values have been created. Now these values means that what is the obtained value. Your TI2 file was what was, or your CIE file was what is expected or what is the actual value, right, of this test chart. What is the actual tri-stimulus value? But this TI3 file is what is obtained after taking the photograph. What is the obtained tri-stimulus value, that is given over here. Okay, so now once this is done, what I'll do is I'll just simply go ahead and go to the next option. That is what I will do is I will write the next option. So let me just move it a little bit so that you can see. So the next part in this process of creation of the profile for your scanner or your camera device is that to create the use the colprof or the colprof, that is the color profile, that colprof command to create the profile for your scanner or the camera. So normally, as you know, I have already told you that profiles for your cameras or these type of devices, they come in different types. They can be either matrix or shaper based, like they can contain only the TRCs and the tri-stimulus value of the primaries, this information, or they can contain more elaborate LUT based profiles also. Okay, so what does it mean actually? This means that we will be creating a more in for your shaper or matrix based profiles, you simply have got TRCs and all these things. But in case of your this thing, in case of uh, your what to say LUT based profiles, they are more sophisticated because they contain color LUTs for the purposes of ensuring that a more elaborate type of a profile is actually obtained. So before we go ahead and use the colprof option or colprof command, let us also go ahead to see what are the options that are available to us in terms of your culprof. Okay, so see, this is the documentation page for the culprof command. How do you get it? Simply go to argylcms.com/doc/culprof.html. So this is the address where you can get, or simply you can change name of the culprof to scanning. So I'll show you how. So let us say you want help with the scanning option. Okay, so simply change the name of the culprof command to scanning, and you will get the documentation on the scanning option. Okay, so then again you want to get some help from regarding colprof. So what are the options that you can use with colprof command? V is the verbose mode that I've already. So what is the meaning of the verbose mode? Let me just go ahead. See, as soon as I click enter, all this information is given in front of me. This is the verbose mode. If we did not use the verbose mode, then this information will not come. After a certain time, the execution will actually occur. Okay. Now, what are the other options? A, you can use name of the manufacturer of the device. M is the model. D is the description. C is the copyright, if any used. So all these options you can basically use to create the color profile, right? Now we will not do this. We will simply use a very simple thing, that is use the culprof option basically. So how to use this culprof option? What we will be using the option to create a profile for the poor man's colorimeter. So what are the options that I wanted to use? So I will write colprof space dash v, which is the verbose mode, uh, dash space dash d, name of the you can see what was that. D stand for description. What will be the description of that particular profile? So D, let me just go ahead and write my phone. Okay, description is my phone, right? So next, then we will write dash qm. What does this qm mean? qm basically is an option where you can use this qm option for one particular purpose. Let us understand what is the purpose of qm. This q parameter sets the level of the resolution of the resulting file. For the purposes of creating a LUT based profile, it sets the main lookup table size and hence detail in the resulting file. Okay. Now, your if you're using the QM as the this QM should be used as a starting point, right? Because here, if you are using a LUT based, your intention is to create a LUT based profile, then of course you need a profile which has got a higher amount of resolution, and that means higher amount of nodes within the profile, right? So the QM then QM tag basically determines whether or not there will be what better to say, what is the resolution of the profile, right? Resolution of the resulting LUTs. That means the nodes are basically fixed out. Now next, the tag that I will be using is AX. AX is determining or telling the culprof command to basically use a XYZ type of PCS. This is extremely useful, or this may provide a very much accurate type of a resulting profile, right? Next, another type of tag that I will be using is UA. UA, this tag essentially defines that it will be forcing the absolute colorimetric rendering intent even when there is this used with relative colorimetric intent that is selected by your CMM by setting a D50 as the white point. Now this will also do another thing, that this is also having the effect of preserving your conversion of colors whiter than the white patch of the test chart without clipping them. And this is extremely useful because in our scenario where we are using a poor man's colorimeter, especially when we are using our phone basically, in that situation this tag uh, is extremely useful for us, right? So once this has been generated, all the tags have been given properly, and the description of the profile has been written as my phone, then what we have to do is we simply have to use the TI3 file. In the earlier section you saw that we created this TI3 file where we got the data of what was actually read by the poor man's colorimeter. Okay, or the what was not the poor man's calorimeter, sorry, we are trying to make the poor man's calorimeter, but what was read by your phone or the scanner that you want to profile. So that information, that color checker photo TI3, here no need to use the word TI3, because we'll be using we can change it later on, the name of the profile we can change also. So now we will go ahead and do all the press enter, and the profile generation will be done. Now see, various information at some points of time will come to you, right? So this is the white point of the of the media. This is the black point of the media. See, A to B tables have already been created, because we have already created the A to B table. Information mostly was available with us, right? Because we knew while preparing the TI2 table, those RGB values and everything was there. So A to B is already there. Now the reverse of it, that is the B2A table, that is going to take some amount of time. So that needs to be mathematically interpreted and mathematically created by this particular your profile maker, that is the Argyll CMS. Now once this is done, then how much well the fitting, the data fitting, how much well it has been done, that data is, this is not your delta E, this is just your data fitting value. So this came, the peak error was around 2.77, and average error is 1.303 around. So this is quite a good fit for our profile. We can say that safely, we can say that this is a good profile, good fit for our profile, because normally this should be not this should really be, Argyle documentation says that they should be around between 5 and 15, but it is much below 5. So naturally we can quite confidently say that the profile that was created is quite the nature of the profile is good. So now what I'll try to show to you is that your the where the profile is being generated. See, this is our profile that has been generated. If you take a look, so as soon as the profile has been created, you see the nature, the icon of the ICC, the type is ICC profile, right? So we can change the name. Let us say that we name this as my phone scanner, right? This is the name of the ICC profile. You can check the properties also. You will see that this is a .icm, this has got a .icm functionality. Now what I want to do is, now I want to first, of course, I'll be applying the profile to some image. But even before that, let us first do something, that is we want to test the or we want to inspect the nature of the profile of the by using this ICC profile inspector tool. So let us do that first, okay? So let me just go ahead and so let me just go ahead and open the uh, your not this one, sorry, yeah. So I'll just show you the ICC profile inspector and also the gamut vision tool. So this is the ICC profile inspector. Yes, this one is the window, right? So you are already familiar with this tool. Now let us open our profile. Now before we can open our profile, what we need to do is, the profile has been generated, is it not? But then there is another problem, which is basically, the problem is, you see, the profile has not been installed in our computer. So normally what we do is, we install all our profiles, or the even the profiles that come pre-installed with the OS, that generally lie in a specific folder in Windows systems. So what is that folder's address? That is this one. So I'll just show you. uh, yes, this one is the address. See, in this location, that is Windows System 32 spool drivers color, this is the location, this is the directory where you can find all the ICC profiles, all the color profiles and the viewing condition profiles that is present or that is pre-installed in your machine, right? Now what you need to do is you simply need to go back to your working folder, you need to copy it, right? And you need to paste it, you need to paste it in this document. As soon as you paste it, it will be appearing. So you see, this is the profile that we have created, my phone scanner, and you can simply press enter or double click it to install it in all the that, to ensure that Photoshop and all the other applications who are capable of utilizing ICC profiles, these are available to all those softwares. Okay, so now let us open uh, the ICC profile inspector and let us try to inspect the profile for a minute over here, right? So this is the thing, the my phone scanner. Yes, my phone scanner is the profile that we want to inspect. So this is how to do it. You simply go to browse, and as soon as you put in the folder name or the location, this folder will open up, and you can select the name of the profile that you want to open and you want to inspect. Over here, as you can see, that this has been created, the CMM type has been Argyll, the device class is input, the device color space is RGB. Since we had used that tag, that dash AX, so we forced our PCS to be XYZ, right? So the platform, the color engine, that is Microsoft, that is ICM based. So I had not given any information about the manufacturer. We can do that by, I think the tag that you had to use for manufacturers was dash M, I think, if I'm not mistaken. Let me just check. No, sorry, dot A, dash A. That dash A is the name of the manufacturer. So if you set your, let us say that you wrote down the uh, you wrote down the command, and instead of, after this D, you added another command. Let us say that command may be the name of the manufacturer. So like this, name of the manufacturer. So since I am making it, let me put my name itself, and then you run this entire operation. Then you can ultimately the generate the name of the manufacturer, and the profile inspector also will have the name of the manufacturer installed over here, right? So this is, again, we have used a relative colorimetric rendering intent, but everything, whenever we do the gamut mapping, the absolute rendering intent will be forcefully applied, right? And again, we can see that although this is your input class, normally in input class, like in Adobe RGB or sRGB, we see that for input classes we have TRC based or matrix or shaper based profiles. But since we did not go for that, we specifically wanted a profile with CLUTs. So that is why we have got A to B matrix as well as LUT, and we have got a B to A LUT. So let us just take a look at the so these are the input channels, right? So you can see a gamma has been applied, right? Most probably a gamma of 2.2 will be applied, as well as these are not calibrated, right? You see, this are not calibrated, so we can calibrate it later on as well. But ultimately your profiles have been created. That is all that I wanted to show you. Now what you can do is, another very useful tool that you can use is, you can definitely, now once your profile has been created, you can just and you have installed the profile correctly, you can definitely go ahead and your uh, open Photoshop and apply the profile to any image that you want. But in that respect also, what I suggest is, Argyle has got that possibility also. So what is that? What is that? To apply a profile that we have just created uh, to any particular image that we have in the working directory. So what is that command? That command is cctif, right? That command is cctif. So how do you apply the cctif command to a particular image that we will be using? What we have got is our uh, image, that is the color checker photo. Let us assume that this is the particular image that we want to apply our profile on. Let us say that this is the image on which we want to apply the profile on, right? So this is the image we want to apply our profile onto, this image, and convert this image using, this is in sRGB mode right now. We want to convert this particular image using the color profile for the mobile phone that we have just created. Okay, so how to do this? We write cctif, then the format is your source ICM source color profile. So source color profile is srgb.icm. So you please remember that whenever you are working with any color profile or any file for that matter, that file should be present in your working folder. That is why I told you. So please put a copy of the, sorry, let me just go back. So yes, please put a copy of the all the files in your working folder. So you see srgb is already there, so that is why we are able to use srgb in this particular context. So this is the source profile. Then what we have is basically your the profile that we want to convert it into. So let us say that we want to convert it into the profile known as my phone, sorry, my phone scanner dot icm. This is the profile that we want to convert it into, right? And then what we have to write is we want to use the name of the incoming file or the input file, so which we want to change. So that is color checker photo dot tiff, and then we want to write the name of the file of the output file, which will be converted into photo converted, let us say converted.tiff, and we press enter. And now it has been done, right? Since we did not use the verbose mode, let us use the verbose mode, so that all the operation that went ahead, that went inside the conversion process, that can also be visible, right? So this was all the entire thing. So now let us see what is the nature of the photo that is being generated. So let me just change the window here for a minute. No, yeah, this is the window. So yeah, so you can see over here that this is the image. This is the image that was created. See, the title is color corrected by Argyll CMS, and we have made the name of the photo also, that is color checker photo converted, right? And this is the original, this is the image that was created. So let us open this image, right? If I open this image, let me just view this. Wait, let me just uh, view this. Yes, so this is basically the image. This is basically the image. So this is your original image, right? And this is your image which has been converted. So this is the image that has been converted, right? So there is a, naturally all the colors have been uplifted, because you see the uh, we will do the analysis later on. We can do the analysis later on using gamma vision and all that. But what I wanted to show you is that there is an overall uplift in the saturation of the color, because it's a mobile device and the gamut of that mobile device is quite large. That advantage has been taken by the profile maker, that is the CMS, and the saturation of that, all the colors have been increased, right? So this is the overall effect of this kind of a of this particular. So let me just maximize this so that you can see it. So this is the converted and this is the original, right? This is the original, this is the original, and you see this is the converted. So naturally you can see that the colors a little bit more saturated. It appears more saturated, more bright colors are available. I don't think I can't see any overall color cast. That's a good thing, that as soon as you are not able to see any color cast, you understand that the profile has got a neutral, I mean there's no change in the white point really. So that is always a good sign, that there is no color cast within the converted image at all, right? Now what we need to do is we can open the gamma vision tool to do some analysis of the quality of the profile. Let us do that. So let me just go ahead and open the gamma vision window. So I'll just bring it up in this particular uh, slide. So yes, so this is the gamma vision window. Let me maximize it. Yes, so let me increase the size of the gamma vision window. So this is it, right? Now what we'll do is we'll open the profile that we have already created, right? So again we go to browse and we select our profile that we have created, right? So this is the phone scanner, and we can view it. We can go ahead and view it. No, so wait, this is, I wanted to show it later on, but yeah, okay. So this is your profile that we have created. You see, this is not really a very good profile. I can't say it's a very good profile. There's a couple of reasons why this has happened. You see, just by taking the look. Okay, so let us try to understand what I am showing you on the screen, right? So the outer wire frame, that is your sRGB profile, and the inner solid frame, that is your output profile. I mean, that is the profile, that is the my phone scanner ICM profile that we have just created with the Argyll system. Now, one thing that you can see over here is that overall the profile is smaller, right? Also, you can see that the gamut volumes is maybe you can say around I think 30% more for sRGB, and it's 30% less for your profile, the phone profile, right? But overall, as you can see, that there is no irregularity in the shape of the profile. So let me just go ahead and if I can browse, if I can just remove this. Let me just check if I can do that or not. uh, I need to find out something. Okay, so doesn't matter. Let me just give you this overview. One thing you can see is that the black point, the least saturated colors, that data is missing in my profile, right? So naturally, because of this also, that vivid blackness in originals, that can also be missing. So naturally, all the colors are a little bit exalted, and the lack of saturation on the uh, dark areas, that are not represent accurately. This is point number one that I wanted to make. Second point is that you see this is a tail. This is a tail of the profile, right? So most in the blue region, right? In the blue violet region and in this region, if you can see, this is basically the tail of the profile. This is not expected. This is not a good sign for the profile. Why? Because why this can happen, you see, if you go through the Argyll documentation, I have prepared my own lab manual also, but what I'll suggest is just go through the Argyll documentation itself. It's complete, and you don't need to search anywhere else for what is happening with your profiles and all. What I really wanted to talk about here, why this has happened with our profile, is that the color patch that we had chosen, the test target that we had chosen, it had only 24 patches. This is the color checker from Greta Magnet. So this is the 24 patch color checker, right? Now this is not really sufficient to create a good continuous profile. That is one of the primary problems for this to have happened. What might have happened is some data must have gone missing in this region, because uh, I've already explained what is the necessity of a good test target. Your test target should be such that all the areas in your available gamut through your for the particular reproduction system or reproduction methodology, that should be represented well enough within your color chart, right, or the test target. Secondly, the distance between the uh, points, I mean the targets of the individual patches, they should be equally distributed, right? Otherwise, what can happen? There may be abrupt jump, abrupt shift in calculation, and some data may go missing. This exactly what has happened. This is exactly what has happened in this particular. Sorry, this is exactly what has happened in this particular chart, right? So you see some data in the blue violet region, had gone missing, and while the since the profile creator did not have this information, they created something of this sort, an irregularity of this sort. They may have extrapolated this type of data, and that is why this has happened. But avoiding this area, overall I would say that the profile in the all the rest of the areas, this looks kind of you know uh, I mean fairly good, fairly regular in nature. Now this is regarding the shape of the profile. So also what we can do is we can use that I had shown you, the earlier one. Apart from gamut gamut vision, you have also that ICC view type of a ICC view type of a command that you can of course use to view your ICC profile. So let me just go ahead and open the documentation for that particular command, so that I can show you what the or how the appearance of that gamut will look like if we don't want to use the if let us say we don't want to use this particular tool, gamut vision. Okay, so for using the ICC, I think the name of the command is ICC gamut command. And using that ICC gamut command, what you can really do is you can create a uh, .gam file which will contain the profile information. Using that gam file, you can then use this gam file along with view gam command to ultimately visualize the gamut that was created. So let us go back to our command prompt and let us use the ICC gamut tool first. So the command is ICC gamut. Again, you are in the working folder. Please remember to be in your working folder before you do this. So then what you need to do is go for verbose mode, and then another tag that you need to insert is w. This w creates a file which is used for or which is helpful for creating that or visualizing that gamut actually. Okay, so next what you need to do is you simply need to write the name of the profile that you want to visualize. So the name of the profile was my phone scanner.icm, right? So yeah, so this is the gamut. So this also is giving you some gamut volume. This is around the gamut volume that is calculated by this command is slightly differing from here. It is I think 7,85,000, but for the volume that was created or that was shown by your gamut vision tool, that was around I think 5,20,000. So that's a difference actually. So that maybe they have sliced off this out of gamut areas. That is why they might have done this. But nonetheless, so the gam file has been generated. Now let us generate the 3D visual effect of the gamut. So how to do this? So if you want to check, so let us check if the whether or not the gam tool has been generated or not. See, this is the xdown tool. I mean, sorry, the gam file. Sorry, my phone scanner gam file or the gamut file has been created. So what you need to do here is next thing that you need to do is yeah. So you need to visualize this. You need to visualize this thing. So the command for that for visualizing is you go for view gam. You want to visualize that, right? So you want to visualize that gamut, and so what is happening, you need to name that profile once again. So my phone scanner, right, .icm, and you need to name that output file. So let us say output gam .x3d.html. So this is how the output file will be stored, and you can visualize this output file in your any browser, since this is an HTML file. Okay, so input file error. Uh, sorry, I'm sorry. I use the ICM file. No, the GAM file needs to be used. That is why we use the GAM file, right? So yes, now it has been generated. Okay, so my mistake was I used the ICM. See, I used the ICM file. So for visualizing the gamut, you need to use the select the GAM file, not the ICM, not the ICM file. So let me just go there. So as you can see that the output file has already been generated. Which one? Yes, this is the output file that we have generated. Okay, so let us open this file and let us take a look of how it is appearing. Okay, so let us just open this file. So I'll just yes, so yes. Yeah, so this is a file. As you can see that this particular file, this my phone scanner, the file that I just opened, this file can be opened. This is a HTML document. This can be opened using any browser. Okay, since I'm using Edge browser, so you can see that the file has you have already opened the file. You can minimize, maximize it, right? And you can visualize the gamut. See, it's a very peculiar nature of the gamut. You see that excess area that was outwardly pushed by the gamut vision tool, that area here also you can see, but this appears to be more smooth. This appears to be more continuous in nature, but this should not be the shape of any gamut for that matter, because these colors are never realizable, right? So nonetheless, this is the shape of the gamut, the 3D view of the gamut that you have just created with the help of your ICC gamut and view gamut commands. Okay, so now your files have already been created and all this has happened. Now also another thing you can do, you can use the that I forgot to tell, that is you can use the CC TIFF file for applying that CCTF into a particular image, that is if you want to convert, oh, that I have already told. But again, I what I intended to say is that you can visualize the particular image using or what is the gamut of the particular image that is being held up, right? So for that, what you need to do is you need to use a this particular command. So no, that conversion or visualization of the gamut within the image, that I don't think is possible. But what you can do is you can definitely visualize the resulting ICC or the gamut of the resulting ICC profile that is available, obviously. Now what I want to do is, now since you have already installed the gamut, I mean installed the ICC profile, now you can use this ICC profile in conjunction to any photo editing or for conversion of any images using Photoshop. So for doing that, what you need to do, you need to open up a Photoshop. Just open Photoshop here for a minute. So let it open, give it some time. So now we have opened Photoshop. Let us open a particular image. So let us open the same image actually. Since I'm using multiple applications at the same time, my computer may have got a little bit slower. So just wait for a few moments for the file to open up. So yes, now the image has opened up in Photoshop. What you need to do is you simply need to go to the edit option, and from the edit option you need to go down, and there will be this option convert to profile that I had already shown you in earlier videos. There you need to select the appropriate profile, but remember that this is going to be a RGB profile, so you are going to find out the profile that you created, that is my phone scanner profile, under the RGB category of profiles, and once you click on OK, the image will be converted, right? So this is the original image, this is the image that you have created really, okay, or the image that has been converted using the this your mobile phone mobile phone profile. So this is the original image, and this is the converted image. So this is how you can do the same thing in using Photoshop as well. Okay, so I think this use of our particular uh, this thing is, clear. Hopefully this became clear to you, that how to create this uh, scanner profile, or how to create input class profile, right? Now what we need to do is we need to go ahead and create profiles for our printers. Okay, the other thing that I forgot to tell you is that before we move on to the concept of how to create profiles for printers, is that how to check the uh, quality, how to quantitatively assess the quality of the profile that you have just created. See, we just by viewing the profile here, we found out that there may be something wrong in the blue violet region, but how much problem it is really creating, that we can also assess using a test which is known as the very popular test, which is of a method to quantitatively assess the quality of a profile, assess a profile. This is known as a round trip test. So what does it mean? What it means really is, first we take a standard image, a test image for that matter, and that image is converted from the device space to the device independent space. In our case, it will be converted to device RGB to XYZ, and then the XYZ are considered, and after it has been converted, then the same values will be used. How this conversion will be done with the help of the profile that we have created, because we have there is this A to B LUTs that is present in my profile. So using this type of a profile, using this type of a CLUT in the profile, this conversion will be done. And after this is done and the XYZs are all noted down together, then the same image, the same converted image will again be converted back to its original device state or device space, that is from XYZ to the RGB color space that it was originally in, with the help of what? With the help of the B2A transforms or B2A CLUTs, right? And the difference between the colors, that is before conversion and after conversion, this is to be calculated. That color delta, color difference is to be noted down, and that is a very nice quantitative metric to identify what is the quality of our profile that we have created. Okay, so Gamut Vision actually provides us with that tool automatically. We can see what we need to do is we simply need to select this option, that is where presently we have selected 3D LAB. From here we need to select this 2D HSL contour plots. Okay, so click on this, right? Once this is obtained, then you click on this option, that is sorry, not this option, sorry, I think, yeah, sorry, this option, not the 2D HSL, the 3D oblique 2D HL, that is hue, lightness, color difference, this plot. Okay, so once this is done, then you need to select your appropriate delta E. So if you want to select delta EAB, let it be delta EAB only. And then we can go for this, select this option. So this will give us a very nice contouring effect. It will be better for our understanding exactly the contour effect and what is the result. Okay, now you see what does this plot actually tell us. Okay, this plot is a plot between the lightness and hue, basically, where you can say that the saturation has been set to 1. Okay, see, saturation has been set to 1, so ultimately it becomes a HL plot, that is hue versus lightness plot, and the resulting color difference that is obtained for this profile after the transformation, that is first A to B transform and then selecting the same image and doing that B to A transform. So what is the resultant delta I that is being generated for which region? So this is the red, this is the magenta, this is the blue, I mean color wise this is given, this is cyan, green and yellow, right? So all the colors are given over here, and if you can move, you can just, I can just show you this. See, these, there are distinct peaks in this blue violet region, right? So whenever, but normally you see, normally the peaks are not that high, right? So you can say over here, you can see over here in the blue violet region, there is, I think, if I can just move it like this, there is a maximum delta I of, I think this is more than 90, around 95 delta I. So this is never a good sign. This type of sharp peaks and all this is never a good sign, right? These type of a plot, these contours, this should be as smooth as possible. Whenever you see these type of spikes, which was also evident from the nature of the 3D gamut that we visualized for this particular ICC profile, there also we saw that kind of a very weird and very unnatural type of a tail coming out in the blue violet region. So that means there some data was missing, and the profile is not continuous in that area. This is also given given us the same result. This round trip test has also given us the same result. So what you need to do is, you simply need to, for conducting the round trip test, what you need to do is, here this is only giving you the 3D HL color difference. For conducting the round trip test, you simply need to go here, that is the this absolute colorimetric rendering intent is provided over here. Then you need to select this round trip to colorimetric, not the perceptual one but the colorimetric. See, here you can actually identify that which area is giving you. So all this area, that means here some data was missing, there is no color in this area, that means some data was missing, and this is around giving us more than 160 170 delta I. So this is never a good sign. That was also given by the absolute I mean, when you were just converting from one profile to the other, that is in the previous one, that when we had selected absolute over here, there we converted it, the profile, from sRGB to our phone scanner, right? This was also giving a lot of delta I difference. But for while you are conducting this round trip test, round trip analysis, which gives you this information that you see this in the output area also, although this does not really hold a meaning over here, but something is very much clear over here. See, this grayed out area has been hollowed out in this image also. That means this blue region, blue violet region, this data is missing. That is why the profile maker, the CMS could not develop that profile, could not build the profile in that area, and that data was, that area was broken out. So that whenever it happens, that is never a good sign. That means you need to change your approach of profiling. So what I suggest is, whenever this type of thing happens, you go ahead and use a more suitable color chart. Maybe for this phone, for my phone using which I for which I created the ICC profile, uh, the color chart or the color checker chart was not a suitable not a suitable color checker or a test target. We needed a test target containing many more samples, many more patches, which were more, you know continuously distributed throughout the gamut. So that is why this entire area, because we had used a chart which did not have original information in the first place, and that was used to create a profile for the device, that is why a lot of amount of data went missing. And in the round trip test, we can see that this is having a delta E of 160, 170. So this is never a good sign actually, okay, for for ensuring the quality of the test. Okay, another thing that I wanted to show you, okay, I think this is one approach I showed you over here for the scanner. When we will develop the printer profile for the inkjet printer that I have with me, for that profile we will do two things. That is, we will do the round trip test as well, and we will do another test that manually I have created that test. That is the difference between color difference between the tristimulus values in the TI2 file and the TI3 file. That is, TI2 file was what is expected tristimulus, and TI3 file we got what we are actually measuring after printing the patches. So that difference, that color difference, I have also measured manually. I've written a very small Python code over here using that color science module. So that will give me the mean or the average delta E 2000. I have used delta E 2000, delta E 2000 for that. Uh, that will determine that before and after transformation, or after before and after printing, or before and after reproduction, what was the difference in color using that particular profile. So that part I will show, that method I will show you while we are developing the profile for our printer. Okay, hopefully this much is clear to you. Thank you for listening.